Have you ever looked at a massive volcanic eruption and wondered what kind of extreme, hidden force could cause an entire mountain to explode? To find out exactly how this happens, we have to reverse time and travel straight down deep into the Earth's center. Below the surface, our planet is split into 4 layers: the rocky crust, the mantle, the liquid outer core, and the solid inner core. Within the superheated mantle, temperatures are so high that rock melts into a glowing, thick liquid called magma. Because heat rises, this magma tries to move upward, but it is pinned down by miles of solid, heavy crust sitting directly above it. Every eruption begins as a surge of trapped thermal energy, forcing its way through the crust as it searches for a way to escape. The magma's escape is possible because the Earth's crust is not a single solid shell. It is actually broken into massive sections known as tectonic plates. These plates are constantly moving. Where they crash together or pull apart, they create escape routes for the magma. The most active of these zones is a horseshoe-shaped boundary surrounding the Pacific Ocean, known as the Ring of Fire. As magma squeezes through these tectonic cracks, expanding gases become trapped inside the liquid rock. It functions like a sealed bottle of soda. If you shake the drink, the gas pressure builds until the container can no longer hold it back. Eventually, the gas pressure exceeds the weight of the rock above it. It forces the magma to violently breach the surface, blasting upwards. This is when the terminology shifts. The molten rock is called lava only when it touches the surface and releases its trapped gas. An explosive eruption is simply the Earth's mechanical pressure release valve functioning as physics demands. Surface volcanoes exist in 3 specific states, depending on how often they vent that pressure. Active volcanoes are currently erupting or have recently released their pressure into the atmosphere. Dormant volcanoes, like Mount Rainier, appear completely quiet on the outside, but they possess an active magma chamber that could wake up later. Then there are extinct volcanoes. Their pipelines are permanently disconnected from the magma source, leaving behind normal mountains, like the rock beneath Edinburgh Castle. Volcanic physics are not restricted to Earth. The largest volcano in our solar system, Olympus Mons, is located on Mars. Closer to home, the majority of Earth's volcanic activity happens completely out of sight, erupting deep underwater along the ocean floor. Whether they are hiding under the ocean, sleeping under snowcaps, or sitting dead under ancient castles, these pipelines dictate the topography of our world. As lava cools and hardens, it creates new landmasses and expands island chains. Even the debris has biological value. Over time, volcanic ash breaks down to create some of the most nutrient-rich farming soil on the planet. We have even learned how to plug into this system, harvesting the rising volcanic heat to generate clean geothermal power. Historically, civilizations have built their cities dangerously close to these craters specifically to use these resources. To keep those populations safe, volcanologists monitor these pipelines using sensors and gas detectors to predict when the next release of pressure will happen. The same heat that fuels these eruptions is what builds the land, powers our cities, and maintains a living planet.